We now evaluate this integral using partial fraction decomposition method. So first, I'm going to rewrite this inside expression inside the integral in terms of partial fraction decomposition. That is, we have this expression x plus 2 over x plus 6 times of x squared plus 1. And according to the partial fraction decomposition, since we have a product of linear term as well as this quadratic term, and this cannot be factored, so we can write this as a over x plus 6 plus bx plus c over x squared plus 1. We put this bx plus c particularly for this factor x squared plus 1, since this cannot be further factored into linear factors. So just remove this. Here A, B and C are constants which we will find now. So let's see how to find the constants A, B and C. Now the common denominator in both sides is the product of these two terms, that is x plus 6 times x squared plus 1. So I'm going to multiply both sides by this expression. So when I do that, I will be getting x plus 2. This is over x plus 6 times of x squared plus 1, and I multiply with this expression x plus 6 times of x squared plus 1, and on the right side I have to multiply each terms with this expression. So this is a over x plus 6 times of x plus 6 multiplied with x squared plus 1, and also the second term should be multiplied with this expression. So I'm going to write down bx plus c, and this is over x squared plus 1 times of x plus 6 multiplied with x squared plus 1. We now cancel the common terms in the numerator as well as the denominator. On the right side, we have this x plus 6 cancels, x squared plus 1, x squared plus 1 cancels. And here we have x plus 6 cancels with x plus 6. And here x squared plus 1 cancels with x squared plus 1. So let's rewrite after doing the cancellation. On the left side, we will have this expression x plus 2. And on the right side, we have a times of x squared plus 1 plus bx plus c. I put a bracket since we have the term, a linear term, that is x plus 6. Now we have to simplify the right side expression and equate the coefficients to determine the values of a, b, and c. So let's do that. We will have x plus 2 on the left side. I'm going to distribute this a into the two terms inside the brackets. So I will have ax squared plus a, and let me FOIL this out. So first I multiply with bx with x, which is bx squared. Then I multiply bx with 6, which is 6bx. And then I multiply the c with x, that is cx, plus multiply c with the c, that is 6c. So we will further simplify the right side expression. That is, I'm going to group the like terms. I group the x squared term with x squared term. And when I do that, I can factor the x squared and rewrite this as a plus b times of x squared. Plus now I group the x term. We have 6bx and cx. So factoring x from these two terms, we'll be having 6b plus c times of x. Now let's group the constant terms. So the constant terms are a and c. So I can put this as a group, that is a plus 6c. We now equate the coefficients of x squared, x, and constant term from both sides. So the coefficient of x squared on the right side is a plus b, and here we don't have x squared term. So we can say that this is equivalent to 0x squared plus x plus 2. And this means we can say that a plus b equals 0. And this implies if we subtract b from both sides, we get a equals negative b. And now let's go equate the coefficient of x term. So on the right side, we have 6b plus c, and this equals, on the left side, we have the coefficient of x is 1. So this equals 1. And let's equate the coefficient of the constant term on both sides. We have a plus 6c, and this equals, the constant term is 2 here. So I put 2. Now we have to solve the equations which has the variables a, b, and c. Since we already know that a equals negative b, I'm going to rewrite this equation in terms of a, so that I will have another equation involving a and c and solve these two equations. So first I'm going to do that. That is, I plug in a equal to, or I can plug in fact, this can be written as b equals negative a. So I'm going to plug in b equals negative a into this equation. And when I do that, 6 times of negative a, that is negative 6a, I'm sorry, 6 times of b is negative a. So therefore, 6 times of negative a is negative 6a plus c, this equals 1. And we have the other equation, that is a plus 6c equals 2. So let's focus on these two equations. These two equations has only the variables a and c. So you can solve it by substitution or elimination method. Let's use the elimination method. So I'm going to write the first equation as it is, that is negative 6a plus c equals 1. Now let me multiply this equation by 6 and add with this equation. So 6 times of a is 6a plus 6 times of 6c is 36c, and this equals 6 times 2 is 12. Now we add these two equations. We see that negative 6e and positive 6c we have just cancelled, and 36c plus c is 37c, and this gives 12 plus 1 is 13. So this implies we get the value of c equals 13 over 37. So we found the value of one of the constant, that is c equals 13 over 37. Now we can do the back substitution of this value of c into one of the equation. I'm going to substitute into this equation, that is negative 6a plus c equals 1. So we have this equation negative 6a plus c equal to 1. So I'm going to replace c by 13 over 37, and this equals 1. So we have to subtract 13 over 37 from both sides. So we get negative 6a, this equals 1 minus of 13 over 37. We can simplify this. We can write 1 as 37 over 37 minus 13 over 37. And this gives 37 minus 13 over 37. This is negative 6a, and this equals 37 minus 13, and this equals 24. So I write 24 over 37. So this implies we can now determine value of a by dividing both sides by negative 6. So it is 24 by 37. Dividing by negative 6 is equivalent to multiplying by negative 1 by 6, which I do now. Now I can do this cancellation. This 24 goes into 6 as 4 times, and this is 1 time. So this implies we now solve for a, and this gives a equals negative 4 divided by 37. And now using the value of a, we can determine the value of b. B equals negative of a. So we see that the value of b, this equals negative of a. So this equals, if a equals negative 4 by 37, negative of a will be positive 4 over 37. So we found the value of b equals 4 over 37. So now that we have determined the values of a, b, and c, we can substitute into the partial fraction decomposition equation. So therefore, we see that this expression on the left side, that is x plus 2 over x plus 6 times of x squared plus 1, and this equals a by x plus 6. So I'm going to replace a by negative 4 over 37 divided by x plus 6 plus bx plus c, that is b is 4 by 37 times of x plus c. I can replace c as 13 over 37. So this is 13 over 37 all over x squared plus 1. And this means we can find its integral since we have written this as a sum of partial fractions. Since we want to integrate it, we put this integration symbol and we also put dx here. So basically we have to integrate this expression. That is this complete integration. So now I'm going to split the right side integral into as many parts. We have this is one part, and this factor divided by this factor gives another factor, and then this factor divided by this factor gives another factor. So basically we are going to end up with three integrals. So the first integral is negative 4 over 37. I can factor out that in front of the integral. I'm going to rewrite this as negative 4 over 37 times 1 over x plus 6. This is the first integral. And then the second integral is 4 over 37 x by x squared plus 1. I can still factor the constant out of the integral and then write down this as x over x squared plus 1, and we have dx. And then the third integral is we have a 13 over 37 divided by x squared plus 1. So I can factor the constant 13 over 37 out of the integral and then write this integral as just x squared plus 1 times of dx. So basically we have three integrals which we have to integrate to find the final result of the given integration. So let's do that. The first integral according to the standard integration formula, this is 1 over x plus 6, and this equals natural logarithm of x plus 6 absolute value. And for the second integral, we can use the substitution method. So I'm going to do that separately here. So that is the second integral is x over x squared plus 1 dx. Here I use u substitution. I'm going to put x squared plus 1, this equals u, and I take the differentials on both sides, so I get 2x dx, and this equals du. Now I solve for x dx, that is x dx, and this equals, I have to divide both sides by 2, so I get du by 2. And this means I can replace this numerator expression, that is x dx. This can be replaced as du over 2. So I put du over 2, and then divided by x squared plus 1 is replaced as u. So basically this integral gets converted to this expression in terms of u. And this can be written as since 1 by 2 is a factor, we take it out of the integral, and this reduces to du over u. And the integral is this is a standard integral. This can be considered as 1 by u du. So integral of 1 by u is natural logarithm of absolute value of u, and then we replace the u as this expression, that is half of natural logarithm of u is x squared plus 1, and then we put it in absolute value. So basically we found the integral of this expression equals 1 by 2 times natural logarithm of x squared plus 1, which I'm going to replace it here. So I put the constant 4 by 37 multiplied with 1 by 2 natural logarithm of x squared plus 1. So I put that here. This is 1 by 2 natural logarithm of x squared plus 1, and this is an absolute value, plus 13 by 37. And this is a standard integral. We have a formula, the integral of 1 over x squared plus 1. We can write down this as simply tan inverse of x, and we also put the integration constant, that is we put this constant, integration constant c. Now let's see if we can simplify this. One simplification that we can do is we have this 4, this will get cancelled with the 2 as 2 times. So it's basically 2 over 37 times of natural logarithm of x squared plus 1. So I'm going to put that over here. So I can put this as, this is simply 2 over 37. So I write 2 over 37 times of natural logarithm of x squared plus 1. So here I have rewritten the expression 2 over 37 natural logarithm of absolute value of x squared plus 1. And so therefore we see that this complete expression on the right, this complete expression is the result of the given integral. And sometimes this tan inverse of x, this is also written as arc tangent of x.